Okay, so this week we're going to be doing Chapter 5 Water Resources. Going to want to be paying a lot of attention to the hydrologic cycle and things like the water table, and I'll show you the slides that are connected to animations so you can watch those animations and videos that are in the study module. So let's go over to share screen. Now, hopefully some of you know where this is. This is an older picture, but it's Lake Mead down, kind of close to Las Vegas. And I want you to see how the dam, how full the reservoir is. And these are the intake tunnels. Then this is the dam itself right there. The water goes in through here and then goes down through the dam, and that powers, the electricity, most of which goes to Las Vegas. So that's a few years ago, and then here's 2007, and here's 2014, and notice how much the water level has gone down, almost to the point where the intake, there's no water to get into the intake valves for to power the electricity. But this was a result of the many droughts we've had. Now it's gone back up, as you can see from this picture, somewhat, and it'll go back up probably after this winter with all the snow we've been getting. But notice, more infrastructure, more towers. They built this bridge so you can go straight over instead of having to come down and go over here. Is a very big visitor center now over here, and you can still tour the dam, I believe, and it's something really cool to do if you ever get the opportunity. But again, water resources are very important, especially here in our state, and we have to keep very careful track of our intake. Think of it like your checking account, where you have a input and then you have an output, and the state has to keep track of this so we know how much water is coming in, how much we're using, and so we can always plan ahead for surpluses, and if we have a deficit, we can make up for it. So notice here, lake's only about 41% full right now, and you can see how high it used to be, and it's dropped 130 feet since 1999. And so every foot that you lose reduces the lake's ability to create electricity. So how did water get to Earth in the first place? Well, when the Earth formed, billions, about 4.7 billion years ago, over time, as it cooled down, it released gases, and those gases were held in place by the Earth's gravity, and they condensed because they had water vapor, and that water vapor basically turned to rain. It came back down and um, uh, cover the earth with water, and that's a process that still happens today. We'll cover that in more chapters, but we see it all the time. This is just a form of outgassing that goes on today. You can see this like in Yellowstone Park, for example, or New Zealand or Iceland, but it happens all the time. And then this is all full with water vapor, goes up into the atmosphere where it will condense and come back down as rain or snow. Now, importantly, water is not evenly distributed over the surface of the Earth. The oceans contain about, out of all the water on the surface of the Earth, the oceans contain about 97% of it. Out of that 3%, that's fresh water, and most of that is ice or beneath the surface. So here's kind of how you can look at it. Now notice there's more land in the northern hemisphere than the southern hemisphere, and that has ramifications for climate, which we'll get into in a couple more chapters. But if you're taking world regional geography, it helps give you some understanding of why there's more population in the northern hemisphere than the southern hemisphere, because there's just more land up there. On the other hand, there's going to be more evaporation over the southern hemisphere because there's more water there, so therefore there is going to be more rainfall. So 97% of the water on Earth is in the oceans. That leaves about 3% as fresh water. Most of that, about 2/3, is ice sheets and glaciers, and the rest is groundwater. About only 1% of this is liquid fresh water at the surface. Very, very, very small amount. Most of it's in lakes, some in rivers, and some in swamps. So we, on a daily basis, we often see lakes and we think that there's a lot of liquid on the surface when there's really not. A lot of freshwater liquid on the surface when there's really not. Again, most of it's ice sheets and glaciers and groundwater. Okay, so some of this water, it escapes into space or breaks into new compounds, but the overall amount very rarely changes. It's going to stay about the same. We have a constant water source. Some evaporates and goes up, and then it comes back down as precipitation. Now that changes, or that doesn't change. That's just what we have here on the supply we have here on Earth. What does change because of global warming is sea levels, and because the amount of ice is decreasing, and as that melts, it adds water to the oceans. Okay, let's pause here and we'll get into the hydrologic cycle on part 2.